Let's prove the following theorem by a direct proof. So we want to prove that the sum of two even integers is even. So the first thing here that I would do is name some of the players in the proof and maybe write it as an if-then statement. Because again, we want to write it as sort of like P implies Q. So one way we could do that is the following. So if M and, so let me use a capital M here. If M and N are two even integers, then the sum, right? So then M plus N is even. Okay, so we want to show this, and this might help us here. So M plus N are two even integers, so this will be our hypothesis, and M plus N is even will be our conclusion, right? So let me put here. So this is the hypothesis, and this is the conclusion. So if I call this P and I call this Q, then the theorem is essentially showing that P implies Q. Okay, so with that done, how can we do this? So again, the way that the proof worked was that we start by assuming this is true. So when we write the proof, we start with let M and N be even integers. Okay. Now, there are many ways to do proofs. One way is to sort of start from the beginning and the end at the same time and try to meet in the middle. And so the idea here is that I know how the proof will start. It starts by assuming the hypothesis. And I know that it will end with something like, therefore, it will end with something, therefore, the sum M plus N is even. So we know how it starts and we know how it ends, and the idea is that you can sort of play in both directions to try to come up with a proof. This is one technique of doing it. I mean, it might be a bit of overkill for a simple proof like this, but sometimes when proofs are more complicated, this can really help. So okay, so we're starting with let M and N be even integers, and as we said before, you need to know the definitions. There's no way of writing proofs if you do not know the definitions here. So what does it mean to be even integers? So that means, so by definition, there exists integers A and B such that M is equal to 2 times A and N is equal to 2 times B. Okay, so this is the definition of being even. And like I said, we need the definition to do the proof. If you are doing a proof and you do not know the definitions of what you're trying to prove, it's impossible to write the proof. You need to go back and check the definitions. It's just how it is, you know? Okay. If I go to the bottom part, I know also that I need to show that M plus N is even. That means that at some moment we're going to end up with some type of thus, for some reason, we have M plus N is equal to 2 times K, for some K, right? And we need to find this K essentially. So we need to be able to show that M plus N is equal to 2K, where K is an integer, right? Okay. And this, I mean, I can even write more, or I mean, this just then implies the definition below. So equal to 2k. Okay. Okay, so now if I look at the second line, so by definition, there exist integers a and b such that m is equal to 2a and n is equal to 2b, and I'm trying to get to talk about m plus n, then I think it's quite natural to just add them up. So then their sum is m plus n equal to 2a plus 2b, and since I want to write it as 2 times something, this will just be 2a plus b. Okay. So now this gives me the idea of what our candidate for k can be. It can just be this a plus b here. So this is how we connect both of these parts. So let k equal to a plus b. Now we need to be careful here because remember in the definition of even, we need k to be an integer. So we need to argue that since the sum of integers is an integer, then k is an integer. And thus we have m plus n is equal to 2k, where k is an integer, and therefore the sum m plus n is even. So our proof is done. So let's go over our proof again just to check. So we want to show that the sum of two even integers is even. So let m and n be even integers. Okay. So by definition, there exist integers a and b such that m is equal to 2a and n is equal to 2b. Okay, that seems right. Then their sum is m plus n, so you just replace here, it's 2a plus 2b, and we can just factor out the 2, and you get 2a plus b. That's great. And now if you call a plus b k, then since summing two integers is an integer, then k is also an integer, and that means that m plus n is equal to 2k. But then, by definition of even, therefore, the sum m plus n is even. And so we just proved that if you assume that m plus n is even, then you get that the sum is even. And that's exactly what we wanted to prove, right? And so once again, notice the structure of the proof. We assumed the hypothesis, m and n are even. Then we unpacked the definition of even. We did some algebra, and we arrived at the definition of even again for m plus n.